So in the next couple of videos, I'm going to show you how to derive the estimators for the slope and the intercept of a linear model, given some data. But first, I want to go over some math rules about summation so that we're all really clear and firm on those. So I'll call this summation rules. And I have 3 of them. The first one is the definition. When I say the sum from I equals 1 to n of, let's say, xi, what I mean is x1 plus x2 plus ... plus xn. So if I have some data about x, and say we observe a sample of x, and that sample is 1, 5, 2, then the sum, and a lot of times I'll just write sum I instead of saying sum I equals 1 to n. It's always 1 to n. Then sum I of xi will be 1 plus 5 plus 2, which is 8, right? Easy peasy. The second rule is that summation can be distributed across a sum. So the sum of xi plus yi will be equal to the sum of xi plus the sum of yi. So all that's saying is that if we have, let's say we have the same sample for x, and then we have a sample for y, and y is, let's keep the numbers small, 1, 2, 1, then to calculate sum I xi plus yi, we can go, x1 plus y1 plus x2 plus y2 plus x3 plus y3 and on. So going, doing this, and then this, right? Or since addition is, you can rearrange stuff under addition. That's also equal to just summing up the x's and then summing up the y's. So that's also equal to x1 plus x2 plus x3 plus y1 plus y2 plus y3. So it should be obvious that's true. One more rule. Clean that up a little bit. Okay, the third rule is that the sum of xi times yi will not generally be equal to the sum of xi times the sum of yi, right? So if that was true, that would say that x1 times y1 plus x2 times y2 plus x3 times y3, so that's what this is equal to. It would say that that's equal to, I'll say it's not equal to because it's not, summing up the x's and then multiplying that by the summing up the y's. So it's not going to be equal to x1 plus x2 plus x3 times y1 plus y2 plus y3. So it can be sometimes in the proofs that we'll do, it can be tempting to try and do something like this, but just remember you can distribute the sum across a sum or a difference. You cannot distribute a sum across the product.